This here is the new grid tie inverter. Let's open it up. Here we go, and that's what we get. Don't think I'll be needing this one. Now this one's slightly different because it takes 22 to 60 volts, so I'll be able to connect it directly to the solar panels. The only issue is my solar panels can actually hit over 60 volts on the input, so they're pretty close just now. It's saying 56.5, so I'm not sure how I'm going to do that. I might just do it connected to the battery and see if there's any adjustment inside the inverter, so I can just turn down the power so it sort of draws a constant power like I could do with the old one. But I'm not sure about that. I will not be taking it apart and oil cooling it because it's just a lot of hassle, and maybe that was why it failed, because I extended the potentiometer. I think what's happened is maybe extending the little potentiometer that I was using to adjust the output power, that was probably maybe picking up interference and then causing problems on the AC side. It's probably best you don't mess about with it. But with my old inverter, the reason it actually did fail before I even played about with it at all, then I ordered new MOSFETs, and then I went from there, and then it failed like what, 2 or 3 times afterwards, so this is why I've got a new one. There's a little bit more to this one. This is the DC side, and the AC side has got quite a lot more on it. So I'll just connect it up to my solar panels and we'll see what it can do. We've got these as well. These are just like screw connectors where you can screw a wire in and then just put them on at a right angle. Also, another issue with me connecting it to my solar panels, that's 1200 watts worth of solar panels on the roof, and that's far too much for this. This is only a 600 watt inverter, so maybe there will be an adjustment inside that I could use to turn down the power so it'll only draw a maximum of, say, 500 watts. I actually believe that this is just the same inside as the 500 watt one, the same physically anyway. I don't really believe that it is actually going to be 600 watts because I never trust the Chinese, well, the rating on Chinese products. In fact, I'm probably not going to connect it directly to the panels because it is pretty close to the maximum rated voltage. It's at 58 volts just now. But then again, that's because there's not much load on it. But even still, they could get up to quite dangerous high voltages in winter. You could get them up above 60 volts anyway. I don't want to destroy this. So I'll connect it directly to the battery. I know what's going to happen. It's going to slowly ramp up the power and probably eventually come close to overloading, and at that point I'll switch it off. Can't see it, but that's just a Tucano turboprop aircraft that just flew by. That's what they train RAF pilots on for their basic jet aircraft training, I think. Just getting these connections done up just now, and I'm just reading the book to see what its maximum ratings are. Trying to find out what the maximum current this can take is. I'd assume probably 30 amps. Yeah, 30 amps is the highest. That's the highest one I could see there. So yeah, we won't be going over 30 amps. Right, now I'm ready to power up the DC side for the first time, checking that all polarities are correct before I start. Because usually when you connect up inverters the wrong way, you get quite a big bang coming off them. Okay, So I'll plug in the AC side. Well, that's quite funny. The cable is supplied doesn't even fit. The connector's like kind of mashed or something, but the cable doesn't fit. So I'll have a look at that. Chinese numpties. Okay, we finally managed to get it crammed in, so we'll switch it on now. Still 0 watts in output. Oh, there we go, we're getting power. Now I'm going to watch the DC side. I'm just going to make sure that that's not going to get carried away with itself and start drawing too much power. I suppose it is better this way, at least inverter is easier to move around and use for other things, such as discharging electric bike batteries, if I decide not to go out. But I'm just interested to see on a 24 volt system if it will actually stop. It's certainly got lots of nice flashy lights on it. Power is still rising quite slowly. 432 out, 460 in. It's making a nice humming noise anyway. The only issue is this will keep discharging the battery, so I'm not sure what exactly to do. If I wire the solar panels back to a 24 volt system, so there's no risk of them putting out too much voltage, then I'm not going to get as much efficiency from this. This is currently at its maximum efficiency configuration, because I've actually got the three 12 volt solar panels in series. I've got 4 banks of 3 in series, so that would be effectively a 36 volt system coming in, and that's converting it down to the lower voltage, and that's the most efficient. So I probably will have to change it over, which will also mean that that amp meter up there will need replaced, because the solar panels, when they're all as a 24 volt system all on series, then they're going to put out too much amps for that meter. I'm talking about the meter up here, not the 50 amp one. But this inverter here seems to have stabilised now on a 24 volt system. I don't seem to be wanting to draw any more power than that. And that seems to be holding steady. But I will supervise it for a bit longer to make sure that it doesn't actually start drawing crazy power and destroying itself. But it seems to be doing quite well. So it seems it is okay to use grid tie inverters on batteries, just as long as you make sure that they're not going to pull too much power. So this one so far seems to be working, and I'll let you know pretty soon if it stops working. Well, it's been running for a good few minutes now, probably about 10 or 15. No fans have come on up yet. It's slightly warm. It's only drawn about 13 amps on the DC side, so it seems perfectly safe to use in this way. So I'm not sure how I'm going to work out a system whereby it's going to divert excess power, and that's what I'm needing to work out. I'm not sure if this inverter is going to get damaged with me switching the AC side on and off all the time. I'm not really sure what to do in that regard, because I think maybe that was what caused the problem with my other inverter. I was switching the AC side off and on all the time, and maybe that's what ultimately damaged the AC side. Maybe it's best to switch the DC side on and off.